Hey everybody! So, today we're going to be looking into something called back titration. Now, a lot of people think, what is the back titration? I know what a titration is. Oh yeah, I watched the last video. Finding unknown concentration of acid or base inside the aluminum flask. Titrating it against a known concentration of what the acid or base reacts with. Yeah, I know. But what is a back titration? Does it mean like backward titration? No, of course not. Don't be ridiculous. How do you do a titration backwards? But what you are doing though is more like backtracking, finding certain unknowns. Now, let me give you a big examples that we're going to do today. And this is actually a classic example. Some people actually do this as as their culminating activities to gain a lot of marks. Yeah. So the experiment that we're going to be talking about today is figuring out how much calcium carbonate is in eggshells. Right? That's why I have a little egg right here showing you what I'm going to be doing. So eggshells, what's in eggshells? What are eggshells made out of? Well, let's say chicken eggs, for example, because that's one of the popular eggs. I doubt a lot of you would be eating like duck eggs, ostrich eggs, some sort of reptile eggs. I don't know what kind of eggs you guys like to eat, but I can pretty much be sure that most of us eat chicken eggs. And what is it made out of? Well, most of it is calcium carbonate. Yeah, the same stuff that you use to make chalk, So calcium carbonate, and there's some proteins, like hundreds of different types of proteins in there. And of course, these proteins are there to crystalline the calcium carbonate. Okay? Why? Well, the thing is, the more calcium carbonate that there are, the higher percentage of calcium carbonate there are in eggshell, I guess the stronger the egg. Right? Just like how people would say, the more calcium that is in your bones and teeth, the stronger your bones are going to be. So maybe, when you get older, some of these calciums get depleted. You should really, invest on calcium pills. That way, you are... your bones don't get broken too easily if you get into like a fist fight or something. And of course, one of the ways to replenish some of the lost calcium is drink a lot of milk. Unless you're lactose intolerant, and then drink something else. Eat a lot of calcium pills, I guess. But yeah, eggshells full of calcium carbonate. The question is, how much? So my unknown is, what is the percentage of calcium carbonate in eggshell? That's what I want to find out. And I'm going to use back titration to figure that one out. So let's say I have let me just put that here. I have 0.5 grams of eggshells. So I guess this is what I'm going to do. I'm going to, boil the egg, right? Boil the egg. It's easier to get eggshells when the egg is cooked. You're going to be making a big mess if not. So yeah, I boil the egg, strip the shells, maybe eat the egg. So I don't waste food. I don't like wasting food. So strip the shells, crush the shells, okay? Because and measure the amount of shells. Let's say the amount of shells in this little quail eggs is 500 milligrams. So it rounds up to be 0.5 grams. Let's say 0.5 grams of eggshells in this, let's say, quail egg, because that's a very small egg. And I crushed it. and I'm going to react it. Now, calcium carbonate, okay, reacts with what? Well, I can tell you right now that calcium carbonate reacts very well with hydrochloric acid. Okay, this is a double displacement reaction followed by a decomposition reaction where you're going to be getting calcium chloride, you're going to get water, and you're going to get carbon dioxide. Okay, that's, the chemistry behind this. And just to make sure that things are balanced, and of course we're going to put a 2 here, okay, to compensate the fact that, all reaction needs to be balanced or else you're going to run into a lot of problem. Now, one thing you have to make sure here when you're doing a back titration, such as this one, is HCl has to be in excess. HCl has to be in excess. So how do you ensure that? Well, I guess you can ensure that by using a high concentration and maybe a lot of volume of it. Okay, so that is something that you set. You want to make sure all the calcium carbonate, is reacted. Because if you have some of these left behind, then the percentage of calcium carbonate won't be accurate. So you have to make sure that all of the calcium carbonate in your eggshells are reacted with hydrochloric acid. So you make sure you use a high concentration, maybe use lots of volumes. That way these are all reacted to become calcium chloride, water, and carbon dioxide. So that's why sometimes we tend to do things more than once at different concentration, just in case, if you set this too low, Now, one information that's probably good to know is if this reaction were to proceed, how many mole of acid was actually used. Now, remember the trick here, the words here is that how much of this did I use? Not how much of this was reacted, because you know that this is excess. So how many moles is 0.5 molarity at 25 milliliters? Well, if you multiply the two number, you'll notice that you used 0.0125 moles. So that's how many mole of HCl you use to react with calcium carbonate. Now, that doesn't necessarily mean all of this was used. No. Okay? What we know here is some of this was used because this is in excess. Okay? Now, knowing the fact that some of this was used, I want to know how much of it was excess. Because you're going to have HCl left over. Okay? Because not all the HCl was used. There's going to be some here that are left over. The question is how much was left over? How much of that 0.0125 mole was unreacted with calcium carbonate? So let's write that down. Okay? So how much of this was excess? Because if I know how much of it is excess, I can use my stoichiometry to find out exactly what this is. So to do that, I will need to do a titration. Because the excess HCl here, from here, is going to react with a known concentration of NaOH that is going to be inside my burette. because the reaction will give me H2O and NaCl. Okay, so again, I'm looking to see what the concentration of this is. I know for a fact that the mixture of these is 25 milliliter of stuff. Okay, I'm going to titrate it with 0.5 molar of NaOH. I tend to go a little higher than or the same. It really doesn't matter. Okay, so I'll put this into my burette. I'll have this stuff, which is really a mixture of this, in my Erlenmeyer flask, and I will titrate. Okay, I will be careful. I will be very gentle. By being careful and gentle, my end point was 10 milliliter. Let's say. All right, that's good to know, because now I have actually enough information to find out what is the concentration of hydrochloric acid that I use. And this concentration is obviously the excess of what's left from here. So let's do the stoichiometry. 0.5 moles per liter of NaOH times 0.01 liter. Okay, we all know that 1 mole of NaOH is equivalent to 1 mole of HCl. Okay, so the mole of HCl is therefore 0.005 mole of HCl. Okay, now I can tell you right now that this information really doesn't matter. Okay, this information is really just there to show you that I took this and I react with my 0.5 grams of eggshells, and obviously I didn't dump it away or took half of it. I took the whole thing and reacted with 0.5 molar of NaOH, and I used 10 milliliters to reach endpoint. But this is the number that I want to know. Because what do you think this number is? That's right. This is the mole of acid that was in excess. Right? I started with this. This is 0.0125 mole. How much of this was reacted with calcium carbonate? I don't know. I will find out very soon. But what I do know is that out of this excess amount of HCl, there was this amount that was left over. This is the excess. This is the amount that was unreacted with calcium carbonate, because NaOH told me so. So if I know how much I use, and I know how much was excess, can I find out how much was used to dissolve the calcium carbonate? Oh, definitely. All I have to do now, let me use a different color. All I have to do right now is take the amount that I use to dissolve the calcium carbonate, subtract that by the amount that was excess that I figured out by doing the titration, and guess what? This was the amount that was reacted with calcium carbonate. Let's write that down. Okay, so this was used originally. This is what's excess, and this is what's reacted with calcium carbonate. Now that's a very good information, because if I know how many moles of this was reacted with calcium carbonate, I can use my stoichiometry to find out how many moles of this was reacted. Turn it back to grams, and I will know how much a calcium carbonate was in my 0.5 grams of eggshells. right? So that's my strategy. That's what I'm going to do. I'm going to do my stoichiometry. So 0.0075 moles of HCl for every 2 moles of hydrochloric acid, it will react with 1 mole of calcium carbonate. So moles cancel, HCl cancel. My answer will be mole of calcium carbonate. So let's see how many grams that is. So for every gram of calcium carbonate, for every gram of calcium carbonate, sorry. What am I doing? What am I doing? So for every mole of calcium carbonate, it is 100 grams. Okay, this will be divided by 2 times 100, so that will be 0.375 grams of calcium carbonate. Okay, so we know by dissolving and doing all the mathematical work that the amount of calcium carbonate in grams for 0.5 grams of eggshell was 0.375 grams. Okay, so let's solve this question then. So what is the percentage of calcium carbonate in 0.5 grams of eggshells? Well, that's simple. Okay, 0.375 grams over 0.5 grams times 100. That would be 75%. Okay. So that's how you find, how much calcium carbonate was in eggshells. And it's a very popular, very, very popular experiment, okay, that a lot of people do. Eggs are cheap, okay? So, you guess you can eat it, but I wouldn't recommend eating anything in a lab. That's one of the things that you should know about. So let's go back and kind of review exactly what we did, okay? So we took some eggshells, okay? We took some eggshells, 0.5 grams of eggshells, and we know that inside the eggshells there are things called calcium carbonate that makes it strong. And I want to know what is the percentage of it. Because I can tell you right now, different types of eggs have different percentage amount of calcium carbonate. Even the same type of eggs will have different amount, right? Not all of us have the same amount of calcium in our bones, right? Some of us has more, some of us has less. A strong guy like myself will have more, some weak dude would have less. Duh. So calcium carbonate, I want to know what's the percentage of this. So I reacted with an excess amount of hydrochloric acid. And again, okay, if you want this experiment to be done successfully, you better make sure that this is going to be in excess and not limited. Okay, you don't want this to be excess, or else, this doesn't work. So I made it to be a high concentration, like 0.5, and I guess use lots of it, okay, just to make sure that this is in excess. So what I did is, do some math and note that, okay, this concentration and this volume represent that many moles of hydrochloric acid. And I know when I took this and I reacted with this, I'm not going to use all of this because it's excess. Okay? Some of it will be used. We found out what it was. Okay? And there are going to be some of this left over. And I took the leftover HCl and I reacted with a known concentration of NaOH in a titration apparatus. By knowing the end point, I found out that, this amount of HCl was excess from this reaction. Yay! So I took this amount and I subtracted by the excess to know how much of this I actually used to react with CaCO3, and that is 0.0075 mole. Well, using my stoichiometry skills, I know if this is 0.0075 mole, this is 0.375 grams by doing this mess, right? So 0.375 grams of this was reacted. That means this is how much it contains. Divide that by the amount of eggshells times 100. I will get the percentage of calcium carbonate in my eggshell. And that was calculated to be 75%. All right. Hopefully you understand the idea of back titration is not really doing titration backwards, but using titration to figure out something, I guess kind of related to what's going on. Okay, in this case, you're titrating the excess of an original reaction. Anyway, I hope you understand this, and hey, I'll see you next time. Bye now.